Hi, in this video, we're going to be working with all four of our sinusoidal transformations. Now, something to note that's important is period and phase shift. Period needs to be factored out. We don't want this B mixing in with that C, and it can look like they are mixing together sometimes, and we need to separate them. You can see here we don't have those parentheses, but it's okay because our B value is 1. However, here, this is not C. That is BC. It's B and C multiplied together. We have to factor out whatever that B value is, just like you can see right here. It's not 2 pi over 3 as our phase shift. It's pi over 3 as our phase shift. So if you do notice that you have a non-1 for your B value, double check that it is not there should be a parentheses there. Make sure that parentheses is there. So let's try one. Oh, here's an example where that's happening. I've got this 2 and that pi. That pi is being multiplied by our B value. So we have to factor that thing out. So let's do that. So we're going to rewrite this as y equals the sine of 2 and then a parentheses and then our x. Plus, well, if we divided that 2x by 2, we better divide that pi by 2 as well. So then we get pi over 2 for this one. Okay, so just basically always divide out whatever your B value is. Speaking of B value, let's write it down. Our B value is 2, making our period to be 2 pi over 2, which is just going to be a pi. All right. Our C value, it doesn't really exist. It's like a plus 0, so nothing doing there. Oh, wait, that's our D value. Oops. Well, at least I caught it. So this is 0. So we're going 0 with our sinusoidal axis. Our C value, that was the one that was causing us trouble. It is pi over 2, and we want to shift that to the left because it's all backwards and weird on the inside of that function. Our amplitude, our A value is 1, so that's far up and down we've got to go. So here we go. Let's graph it. I'm going to be going to the left, so I'm going to need a little more space over here. I'll get to there in a minute, though. 1, 2, 3, 4. Write down my period, which is pi, and then halfway is pi over 2. Our sinusoidal wobble is going to be going up and down. 1 and down to -1. And then I need to go pi over 2 to the left. Well, it seems like I've got 2 ticks. 1, 2 ticks is going to be pi over 2, and I got to go to the left. So I'll go 2 ticks to the left to get to negative pi over 2. And that is where we're going to start our sinusoidal wobble. So we'll start right here on, then up, then on, then down, and on. And since I got the other tick marks, I might as well just keep wobbling. Woohoo! Whir. All done. In this example, again, we've got a B value and a C value that are mixing with each other. No. I don't like that. So we get y equals 3 cosine. We want to factor out that 4, so 4x. Minus, and then that pi over 5. We want to divide that by 4. So that is going to be pi over 5 divided by 4 is pi over 20. So our C value is going to be pi over 20. That's just going to be a little wobble. Little tiny little shift. And it's going to be still going to, this one's going to be going to the right because it's subtraction. And then we're going to go, our D value is nowhere, so we're going to be going up 0. Our B value is that 4, and so our period is going to be 2 pi over 4, which is just going to be a pi over 2. Our amplitude A is going to be 3, so that's how far up and down we've got to go. Oh, I don't ever write the N. Okay, it's going to go pi over 20 to the right. Well, that's just going to be a little tiny little bit. So basically just a bunch of our tick marks are just going to be off a touch. Write our period 1, 2, 3, 4, pi over 2. Halfway is going to be pi over 4. My amplitude is going to be up and down 3. So 1, 2, 3. My sinusoidal axis has not shifted. 1, 2, 3. -3. Now we want to go pi over 20 to the right. So it's going to just be a little bit, because if we think about this is going to be pi over 8. And then so this would be like a pi over 16 right there. So it's just going to be just a little bit off. Just all of our points are just going to be a little bit off. And that's okay. We don't we that's about how accurate we need to be. We don't need to actually make these 20ths. That's all right. So our next tick mark, again, it's just going to be a little bit off of where we're supposed to be, because it's going to be a pi over 8 plus a pi over 20. So this one's also going to be a little bit off. This one's going to be a little off. And that one's going to be a little off. But they should all be a little bit off to the right. And then we draw a wobble. Woo! And there's our cosine graph. In this one, we don't have anything really going on with B and C. They're behaving each other, especially since that B value is 1. We don't have major worries. So our period is going to be 2 pi over whatever our B value is, in this case 1, which is 2 pi. Our C value is going to behave itself, which is going to be a pi over 3. And since we're adding, we want to go to the left. This is all backwards and weird. Our D value, nothing is being added to the outside, so we're not going to be shifting the whole function up and down at all. Our amplitude is going to be 2, so that's how far up and down we will wobble. I thought real hard about making sure I wrote that in. I want to go to the left, so I want to leave a little bit of space over here. Period. 1, 2, 3, 4. Period. 2 pi. Pi. My amplitude is going to be 2, so I want to go up 1, 2, down 1, 2. So we got -2 and 2. Next is finally is my pi over 3 to the right. Now, this is going to be pi over 2 right there. So it shouldn't be as far as that. But I want to use those same tick marks. So I should just be a little bit short of that pi over 2. And I'll even do it like properly off of the top. So we just want to go pi over 3 to the right. It should be almost a pi over 2, but not quite. Almost there, but not quite. So we'll go up. And then, let's see, I want to be on the other side, but not quite at 0. And then not all the way there, not all the way on, and then up. And then I could do one more back on. And here's my curve. And it doesn't, and mostly I'm looking to check these numbers. It doesn't have to be a perfect graph. We have better things to do than make number lines. In this example, I can see that B and C are not behaving each other. They're kind of intermixing, and I don't really like that. So we got to factor that out. So we get y equals 3 cosine. Factor out that 1/2. Since we divided 1/2 x by 1/2 to factor it out, we also have to divide x pi over 2 by 1/2. So pi over 2 divided by 1/2 is the same as multiplying by 2. Dividing by half is the same as multiplying by 2. That'll cancel those 2's, so we'll just have a pi over 1 or just a pi. Think about what would happen if you distribute that 1/2 in. You get pi over 2. Minus a 2. So let's deal with that. We got a down 2. So we got 2 down on our sinusoidal axis. We've got a shift of pi. Since it's being subtracted, you would think it would go to the left, but it's going to go to the right. And then our b value is 1. No, not 1/2. It's 1. It's 1/2. Sorry, I've done too many examples where the period was 1 or b value is 1. So we get 2 pi divided by 1/2. And as we just discussed, dividing by 1/2 is the same as multiplying by 2. So we get 4 pi. And then our amplitude is going to be 3. That's how far up and down we want to wobble. We're going to be shifting to the right, and we're going to need to go down. So I'll kind of do something like that. That might be good. Hopefully you have a little bit more room on your paper. 1, 2, 3, 4. And then we write our period, 4 pi. Okay, halfway point is 2 pi. So that's pi. My sinusoidal axis is the next thing I deal with. It is going to be down 1, 2, down here at -2. That's where my horizontal sinusoidal axis is going to be, what I'll wobble between. From that sinusoidal axis, I want to go up 3 to 1 and down 3 to -5 in my wobbles. And then I also want to start by wobbling pi to the right. So normally I would start right here at up, but I'm going to shift over pi to the right. That means I'll need one more tick mark over here on the end. That'll be at 5 pi. So do my wobbles. So we start up above the sinusoidal axis, then on the sinusoidal axis, down, on, and then up. There is my cosine curve. I could probably put one more point there. Why not? I have it, so I might as well do it. There's my graph. In this one, B and C are not behaving themselves. You got it. You can't hang out together. You got to separate yourselves. So let's factor out that B value. So we get 4x minus, we want to divide that 4 pi by the same 4 that we divided x by, our B value. So that's just going to be pi plus 1. So that 1 is our D value. So that's going to be 1 up. Our phase shift is pi. That's going to move it pi to the right. Right? Why would you do that? Right. Our period, our B is 4, making our period that 2 pi over our B value, which is a pi over 2. Right? Yeah. Okay. Then our amplitude is -3. So let's see, that is going to be up and down 3, but it is going to be flipped because it's negative. So we'll just have to remember that rather than going up first, we're going to go down first. So we'll just kind of make a little adjustment up here for that flip. So we'll go wee like that instead. Okay. So here we go. We're going pi to the right. So I want to have space over there and I want to go up a little bit. So here I'll go like that. So 1, 2, 3, 4, write my period. And then pi over 4. And I want to go, oh gosh, I want to go pi to the right. I don't have that kind of space. What do you think? I'm made out of space? Pi to the right. I want to go 2 periods to the right. And since this thing wobbles infinitely, that pi to the right really doesn't do anything because I would take this point and I would move it to here and another one would take its spot. And then I'd move it to here again and another one would take its spot just as before because you've got to remember this thing is infinitely long in both directions. So that pi to the right isn't going to really do anything. So I'm going to ignore it because it would have gone, whoop, let me draw it. It would have gone, whoop, whoop, but a point from over here would have just filled in its spot. That pi to the right is not going to do anything. So I'm going to ignore. If you really want to, You could draw a super wide graph. You can have fun with that, but I'm not going to do that. I don't have enough space. I'm going to go up one. Normally, I don't give you examples that are that far off, but let's see. I want to go 1, 2, 3. So 1, 2, 3 down to -2, and then 1, 2, 3 up to 4. I'm ignoring my phase shift. So later. So we go on. I can't ignore my flip though. Down, on, up, on. And there we go. Okay, I felt it. I felt it. People didn't like that idea of what I was talking about, so I made this thingy. So I graphed our original one, and just to make sure that you're cool with what I did is I factored it out, and you can see that that doesn't change anything. So we get that same thing. Now, watch what happens. If I get rid of that minus pi, it doesn't matter. And then I made this because I was feeling really adventurous. Watch this. So this one is going to move and it's going to shift back and forth between negative pi and pi. And you'll see that every time that it kind of hits a pi, it lines up because that thing is infinitely long. So as it shifts left and right, it don't matter. It don't matter because it just kind of fills in the gaps. Isn't that cool? Oh, I hope you appreciate this cool animation. Oh, now I'm going to get rid of it before I throw up. Oh boy, there are a lot of twos in this problem, but we want to make sure B and C's got to be separated. You can't separate yourselves. So 2 sine of 2 parentheses x. So we want to divide that 2/3 by 2. So dividing by 2 is the same as multiplying by 1/2. So that 2 pi over 3 dividing by 2 is the same as multiplying by 1/2. That'll cancel these 2's, and we're left with just a pi over 3. You can check that too by if you multiply that 2 in, that 2 times a pi over 3 will be 2 pi over 3. Okay, cool. All right, so our d value is 0. We're going to go nowhere up and down. Our phase shift is going to be pi over 3. It's being subtracted, so that goes to the right. Addition would be to the left. Our period, nope, our b value is 2, so our period is 2 pi over 2, which is just pi. And then our amplitude A is going to be 2 up and down. All right. So here we go. We go whoop, whoop. 1, 2, 3, 4. Write my period. Pi. Then we got pi over 2. We've got nowhere in our sinusoidal shift, so we're just going to keep that right in the middle and do our amplitude. So up 1, 2, down 1, 2. So -2 to 2. And then we want to go pi over 3 to the right. So I know that this is going to be pi over 4 right here. Pi over 3 is in between pi over 4 and pi over 2. So my shift for sine is going to put me like between these two. So I just want to keep my points in between these two. I'm going to need another tick mark, and I might as well just make another one for good measure. Yeah, good measure because we're kind of measuring. Pun not intended. All right. So we'll start kind of like in between because we don't need to be perfect. So at pi over 3 to the right, and then we'll do our sine pattern. So we'll go up, on, down, and then on. On, up, on, down, on. Woo! There is my sine curve. Hooray! In this example, B and C have decided to separate themselves. They're cool with not being right next to each other all the time. Thanks. So we don't have to do any factoring out. So we just need to go through and identify our stuff. Our A value is -5. So that is going to be how far up and down we need to go. However, it is going to be flipped. So we'll make a little note for ourselves. Hey, flip that thing upside down. It's going to go like that now. Okay. Our B value is 1/4. So our period is going to be 2 pi divided by 1/4. So you want to think about, oh, well, dividing by 1/4 is the same as multiplying by 4, or just multiply the fraction out. You multiply top and bottom by 4, and you get 8 pi. Our C value is 3 pi. It is being subtracted, so that means it's got to go to the right. And our D value is 0, so we're not going to shift our sinusoidal axis at all. So here we go. 1, 2, 3, 4, 8 pi. Halfway point is going to be 4 pi. This one's going to be 2 pi. And I don't know why I did that one too. That's what I felt like doing, okay? Don't come after me. Then our amplitude is going to be up at 5. So I'm just going to make a tick mark up here and say 5. Can't be bothered to make 5 tick marks. What do you think I'm made out of tick marks? Then we got to move 3 pi to the right. So 3 pi to the right is going to be somewhere in between 2 and 4. So right there. Great. And then we do our wobble. Whoa, get rid of that. We do our wobble. So we go on, but we got to go down first because it got flipped. On, down, on, up, on. And then why don't I just make one going backwards? So that one will be up. Ooh, that's a terrible curve. But you get the idea. It's kind of wobbling between those 2 points. I care about the points and you figuring out those values and less about the graph. All right, in this example, B and C, what have I told you about hanging out together? I have told you and I have told you, but you cannot be together. Get out. No. No. Now, the pi over 2 gets divided by a pi over 2. Pi over 2 divided by itself, oh, that's just 1. Whoop. -2. -2, guess what? You're our D. So that is going to be 2 down on our sinusoidal axis. So all of our points need to move down 2. Our phase shift is going to be 1 to the left. 1 left. And then our B value is going to be pi over 2. So our period is going to be 2 pi divided by pi over 2. So if I try to simplify that, I could multiply out the divide by 2. So that would be 4 pi over pi. But hey, wait, then the pi's cancel. So our period is 4. Oh, neat. Well, guess what? That's just a number. All right. Our amplitude is just A, so that's just 1. Well, hey, now we don't even have goofy pi's going on. I know exactly where 4 is. You go 1, 2, 3, 4, and then you write a 4. Oh, wow. Don't freak out because guess what? Our C shift is a nice whole number too. Ah, thanks, friend. We want to go down 2, so we'll do our sinusoidal shift. 1, 2. So -2. Bop, 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 bop. Our amplitude is 1, so we want to go up and down 1 from this point, from this line. So we want to go -3, and we gotta go to -1. And then we want to shift 1 to the left. Ugh, I don't have space over here. -1. Left. To right there. Once we got there, time to do our pattern. So on, up, on, down, on. and an extra up just for fun. And there is our sinusoidal curve. So ends our sinusoidal transformation video. So here's the slide that we started out with. I added on, if you haven't noticed, there's a pattern to doing these transformations. You'll always do them in the same order. First, you will be graphing your period, followed by making your sinusoidal axis for any vertical shifts that happen. Next, based on where your sinusoidal axis is, do your amplitude up and down from the sinusoidal axis. Shift either left or to the right for your phase shift, and then finally make your wobble, either the sine wobble or the cosine wobble. Don't do all those steps and then choose the wrong wobble. Thank you for watching and have a great rest of your day.